Alright, in case you can't tell, I'm not an artist, not going to quit my day job. This is a model of IgG, which is the most abundant antibody in our blood. Its functions are to neutralize toxins and viruses, promotes complement and opsonization, induces natural killer cells to promote ADCC, and it crosses the placenta to protect unborn children and protects babies through breast milk as well. So the different regions here, the variable regions are up in this top half here, and the constant regions are down here and these areas here. They're located at the N-terminal ends of the H and L chains. The variable regions differ between antibodies produced by different B cells, and they make up the antigen binding sites, which are at the ends right here. The antigen binding sites, there's a variety of ways that they can bind. There's pockets, complementary surfaces, or a protrusion fitting into a pocket on the antigen surface. These variable regions here change because different antibodies have different BCRs to bind to different antigenic epitopes. The two variable ends on the antigen binding sites of the IgG molecule are exactly the same on any given antibody. So then we also have the constant regions here, here, and here, located at the C-terminal ends of the H and L chains. They help to give antibodies their characteristic shape and hold the chains together. The C regions of the heavy chains are responsible for the antibody's effector functions. That means opsonization and complement activation. And that part of the antibody molecule may bind to receptors found on the surface of other immune system cells like macrophages, mast cells, eosinophils, and natural killer cells. The heavy chains are the blue ones here, and the light chains are the yellow ones here. The heavy chains are about 440 amino acids in length, and the light chains are about 220 amino acids in length. The light and heavy chains are held together by disulfide bonds, and the two heavy chains are also held together by disulfide bonds. The two light chains are identical, and the two heavy chains are also identical on every antibody. The hinge region, what I was pointing to here, where that little blue sticky stuff is flexible, and it can bend to fit different antigenic epitopes, and there are many different orientations, so these arms will bend down to fit different epitopes. And the FC region, that is the crystallizable fragment portion at the bottom of the Y shape. So down here, if you were to cut this off, this would be the FC region. And there are two identical pieces of heavy chain at the C-terminal region or the constant region. And that is the IgG immunoglobulin G antibody.